Hi, this is a quick update to my Blinkenlights enhancements for my homebrew computer. There was a comment on Twitter saying maybe I could use a 555 timer and use a variable capacitor or resistor to change the speed of the lights. But that's not really going to be possible because what I want is the Blinkenlights to actually reflect the operation of the computer, not just for effect. Well, it is for effect, of course, but you know what I mean. You know, the lights are actually showing some real functioning that's happening inside the computer. What you saw in the other video is the LEDs which are connected to the address bus, which most of the time are kind of on. And then there's some LEDs connected to the ROM bank number, which sometimes you can tell what's going on depending on the function that the computer is executing from bank 0, 1, 2 or 3. But they're not very easy to spot, and the 555 timer suggestion made me think a little bit more about other sources of signals. And of course there is an obvious signal which is much slower than megahertz, and that is the vertical blank interrupt of the video chip. So that's what I've done here. I've got a 12-bit counter, a 4040. This wire here that my pen's just pointing to, this yellow wire, actually comes from the TMS 9918A's vertical blank interrupt pin, and it basically provides the clock pulse to the 4040 12-bit counter. And then I've just got the LEDs, four LEDs at this point in time, connected to I think it's bit 2, 3, 4 and 5 of the counter. So what we're seeing here is the computer 60 times a second is being interrupted by the TMS, and that changes the interrupt level pin, and then the 6502 needs to service that interrupt, and when it services that interrupt then the pin goes high again. And so essentially there is a regular high-low transition, and that's what is being picked up by this counter. Now interestingly, this isn't just a free running counter, it is driven in software by the computer, and I can show you how this can be affected. So the interrupts are always running, and they're very important because these interrupts, the 60 hertz interrupt also is used as an internal counter. So some of the delays within the keyboard scanning and other things rely on this interrupt. However, when you are doing graphics operations, you need to make sure there are no interrupts happening so that you can ensure that you transfer commands to the video chip without an interrupt messing up that stream. And I can demonstrate that reliance on interrupts or not wanting interrupts to happen to at any time. So you can just see on the screen there, the basic is booted up, the lights are flashing at a certain rate. Now if I put the computer into a constant state of going into high resolution mode, and the reason why I'm doing that is that high res mode requires quite a few commands to the video chip, and each time a command is being sent to the video chip the interrupts are disabled. And so what we'll see is that whilst high resolution mode is being constantly set from basic, the interrupts will slow down. So let me just show that. So you can see how fast the lights are flashing, and then if we go now, and you can see that it's slowed down, and that's because high-res mode is copying lots of graphics from into video RAM, which requires interrupts to be off, and a lot of data transfer happening basically. So during that, each of these commands, we need the interrupts to be off, and that's why it's now slowed down. If I Control C on this, and now you can see it's speeded up again. I need to go back to mode 0 so we can see the screen again. But yeah, that shows that this is a software-driven signal rather than just a free-running counter that's showing some nice lights. The other thing that I've done is to also hook up one LED to the sound chip. So the sound chip, the AY38910, is activated on two occasions. One is when you're trying to play or send a sound command to the chip, and the other is when you're trying to read the joystick status through the I/O port that the sound chip also supports. So I've hooked up, and I'm going to try and see if I can show this LED. It's just here. Oh, you can't see it. Let me just go down, and it's just here. There's an LED just there, and I'm pressing enter on the keyboard right now. You'll hear a little buzz from the speakers because all I'm doing is telling the sound chip to turn its speakers off, and that creates a tiny blip. So here goes. Did you see that the LED has now lit? It's very dim because most of the time it's in basic going around the loop, and then for a fraction of the time it's sending a sound command to the sound chip, and that's why during that point in time this LED lights, but not for very long, so it's quite dim. And if I control C out of that loop, you can see that light goes off. So now I think I've added enough blinking lights on this project. That's my blinking lights project done. And what I'm going to do next is, well, as I said, there's some other enhancement projects that I'm thinking about, but more to come. But hope that makes sense. These are real blinking lights, not just some free-running timer just for effect. They are showing the genuine internal operation of this homebrew computer.